Oh, g'day. My name is John, and this is the second in a series of videos that I'm doing on these little Chinese diesel heaters or parking heaters. This is the one we'll be bench testing today, but I'll go through a little bit before we start. First, the operation of the heaters. In here there is a stainless steel burner underneath, and it acts like a blowtorch. It provides heat that's transmitted here to the external heat sink, which is made out of aluminium with a lot of fins in it. Cold air is drawn through this side of the heater, passed over these fins and expelled out the exhaust. The little heater is controlled by an electronic control unit under here and the control panel. Today I'll be using one of these simple digital control panels so I can manually adjust the pulse rate, which is the frequency of the fuel pump. In here there's only one moving part. There's very little to go wrong with these. So if set up correctly and operated correctly and understood, there's very little that will go wrong and they become excellent little heaters. Okay, so the fuel is supplied by what we call a dose heating pump or a metering pump. It's a little pump like this. In here, this part here, there's an electromagnet, and inside here there's a very tiny little piston, and it has a chamber up the top, and so when the electromagnetic is energized, the little piston flies up and squirts out a metered quantity of fuel. Now, most people have no understanding about how small that little metered quantity is. It is exactly the same every time, and in these little diesel heaters the metered quantity of fuel that is injected per pulse is 0.02 of a milliliter. Now 0.02 of a milliliter is very tiny. As an example, if you have an eyedropper and you do one drop, that one drop of fluid is 0.05 of a milliliter. So each pulse of this little heater is less than half a drop of fluid. Now here's an example. That little drop in there, that is 0.02 of a milliliter in a teaspoon. Now the average teaspoon holds about 5 milliliters of fluid. So to fill that teaspoon, this little pump here would have to pulse 250 times. Okay. We're running it off a little motorbike battery, and the current temperature is around 21-22 degrees. I'll just set up with the test instruments and then we'll come back. Okay, we're ready to go. I've connected power and we're drawing about 0.13 of an amp, and that power is drawn by the ECU. We have a fully charged battery. We've got our controller all set up. Our current temperature is 21 degrees, and we'll start it, just one short pulse, and then you'll see this light come on that when it's operating. Okay, so the machine now will go through its startup process. First it'll start the fan, then it'll do checks on the fuel system, the electronic control system. It'll sort itself out that everything's working correctly. It'll turn the glow plug on. Now the glow plug will heat up to red hot, and when that is red hot, the machine then will turn on the fuel pump. But not until the glow plug is hot will it turn the fuel pump on, so you don't have raw fuel going into the system that can't be burnt. Turn on the glow plug. Now this will run about 8 to 10 amps. Okay, the system will now take a few minutes to get itself going, and we'll come back. Okay, the little heater is stabilised. I'm running at a manual setting. I run it at 3.6 Hertz, so that's a pulse frequency of 3.6 Hertz, which means that the little dosing pump here is doing 3.6 pulses per second, so each pulse is putting out 0.02 of a milliliter. This is probably a mid-range setting. At that we're pulling about 2 amps. Okay, I've got a dual range thermometer here. The bottom one is the ambient temperature, so we're running about 21.8. On the top one, I've taken the probe and put it on the hot end of the heater. So the cold air comes in this side, goes across the heater, out this side. So we're running 33, 34. This can get up to 50 degrees centigrade on this side. This here is ambient temperature. The important thing to look at, here we've got 68, 69 degrees, measured 1 meter from the burner. So I'm measuring this that's at 500 millimeters, 500 millimeters from the burner. The important thing we need to know is the difference between the air going in and the air coming out. So we've got roughly 21 degrees going in and 68 degrees going out. So we're looking at around the 48, 50 degrees increase in temperature. And these little heaters go between 50 degree increase and about 80 degree increase depending on the setting. It is the change in temperature that we're looking at, not so much the actual temperature. Okay, we're running at about a mid-range here. What we can do is I can put an anerometer on the intake air and we can tell the volume of air going through it, and we can do I suppose a workshop test of the output of these heaters. And I've done it already for this heater. So these little heaters, they say it's a 5 kilowatt heater, but we're actually going a little bit better than that. It's actually putting out 5.6 kilowatts. The other thing I want to show you is how clean this heater runs. These little heaters, if they're set up correctly and they don't have restrictions in the exhaust or the intake line, they run very, very clean. No smoke, if you know, no smoke on startup, no smoke at all. Down here I've got a domestic carbon monoxide detector, and in all the tests I've done, it's never moved off naught. If you have a look at this, it might go up to six, maybe 7 parts per million of carbon monoxide. So it is running very, very clean. And as you already know, if you have complete combustion, you've got the fuel mixes with oxygen, and on complete combustion you produce carbon dioxide and water vapor. So just the same as a human sucks in oxygen, they convert that oxygen into energy, and then that from the food that we eat, and then we blow out carbon dioxide and water vapor. Now, what's so nice about this little heater is that it puts out about 8 ppm of carbon monoxide at the exhaust. Very, very clean running. As an example, 8 ppm is the recommended dose for workplace health and safety over an 8-hour period, whereas 50 ppm is the maximum that OH&S recommends. But as a comparison, if you're a smoker, you're going to be putting out probably 1,000 ppm in the, or 1,700 ppm in the exhaust smoke that you blow out. All right, I'll take it down now to a lower setting. The lower setting here is 1.6 hertz. So what we're doing is I'm manually adjusting the fuel input into it, just like an accelerator. You put the accelerator down, you put more fuel into the car, you let it up, and the fuel reduces. So we'll take it down. 1.6 hertz is at the lowest. We'll let it stabilize at that, and I'll come back. Okay, the little heater is stabilised at 1.6 Hertz or 1.6 pulses per second, which is the lowest speed this one will run at. Running very quiet, you know, about 50 decibels, and I'm talking now so it's jumped up. And we're on the exhaust side. So it's running about, averaging about 63 decibels, about a foot, 300 millimeters from the exhaust. Now I want to show you two types of mufflers. I've got two little stainless steel mufflers here. We've got a straight through muffler. So what it does is it goes straight through. Inside here the tube has a number of holes drilled in it, and it is then filled with a sound absorbent fiberglass material. On this other muffler you can't see through it, it's sort of baffled. So what happens here is the exhaust pipe comes down in a U and then back out again. So as it comes around, it's got all the little holes in it. It also has an absorbent fiberglass material inside to absorb the sound. The flow through is by far the best because it does not have back pressure, it doesn't create back pressure on the exhaust. This little muffler creates back pressure because of the way it curves around and everything. Now the interesting thing is, most people would say this baffled exhaust muffler is quieter than the flow through muffler. That is not the case, so let's have a look. Okay, we've brought it down to about from 60 odd to 64 decibels, about 57, 58 decibels by putting the muffler on. Now we'll try the other one. So it's come down to 59, 60. So in consistent testing that I've done, the actual flow through muffler, not only is it more efficient and not creating any back pressure, but it's actually 2 decibels quieter than the one with the U-shape and baffles in it. So by far a better muffler. Now as 10 decibels is doubling, if you got 2 decibels, this one here, the flow through muffler, is 20% more efficient than this one, and it creates almost no back pressure. So if you have a choice, make sure you buy one of these flow through mufflers. Alright, we've got an increase in temperature, output there of 84 degrees. We've got an ambient of 22, so about 62 degrees increase in temperature through the unit. Okay, I'll take it up to full power. On this little machine it's 5.5 Hertz. Right, we'll run up full power and have a look at it in a minute, so I'll be back. Alright, we're stabilised on maximum power, or sometimes called boost power. We're running about 80-82 decibels of noise. Exhaust gas temperature of about 160 degrees centigrade. Still running only 8 or 9 ppm of carbon monoxide, so we're still running very clean. So we're looking at a 4 decibel reduction in noise. Ambient temperature 22 degrees. Our case here is up around 40 degrees centigrade. Really only warm to touch. This end is cool. Only about 98, 97, 98 degrees change. So we're up about the 70 to 80 degrees increase in temperature there. All right, I'll show you an example of how this is running so clean. The most important thing is that you do not have back pressure coming through the exhaust. It's got a sealed combustion chamber in here, so the inlet air has to have no restrictions. If you're going to run a long one, you need to increase the size of this inlet, so there's no restrictions in here. But because this is a closed combustion chamber, if you restrict the exhaust, then you won't allow the inlet air to come in. As you know from school, when you have combustion, complete combustion, you have to have air. So if you have incomplete combustion, it's normally a lack of oxygen, which is normally a restriction. And in this case, you're not getting enough oxygen through, so you've got restriction here, or you've got back pressure here. All right, we'll slow it down a little bit, and then we'll shut it off. I'll go down to what would be a high setting of 4 Hertz. We'll let it stabilise at that for a little bit. And then we shut it down. Just before we do, I'll actually show you the difference between this exhaust, nice clean exhaust, and a motor car exhaust. Okay, this is a diesel motor car. If they could make a motor car efficient like the little Chinese air heater, we'd have so much less pollution in our cities. Another thing on the fuel side I'd like to talk to you about is in this little dosing pump there's a tiny little piston, I mean a very tiny little piston, that runs up and down. Now it flies up and down here like we're currently doing 3 Hertz, so it's up and down 3 times every second. At full power it's up and down 5 and 6 times every second. Now as that little piston runs up and down, it creates a low pressure as it sucks in the fuel. So the low pressure then creates turbulence, and the turbulence create bubbles. So in the fuel line you will always have tiny little bubbles, and that is quite normal, and that is how these little pumps operate. The little bubbles are normal. If you have a big bubble, then you've got a leak. Now because these little pumps create bubbles in them, it's very important that when you mount them upright or at an angle, because otherwise if you lie them flat, what happens, little bubbles collect in here, create big bubbles. That upsets the whole dosing rate and also causes wear on top of the piston, because the piston is lubricated by diesel. If there are bubbles on top of the piston, then it is going to be metal on metal wear. All right, we'll come back a bit later. Okay, I've shut it down now. A long press on the off button, flashing of the little indicator light here, and it'll start the shutdown process. It's very important that you set these up with its own circuit breaker, and it's not on a master switch, because if you shut that down and you don't let it do the rundown cycle, then you can badly overheat the unit here, then will fry the ECU underneath here. So what will happen is it'll slow the unit down, it'll cut back the fuel, it'll turn on the glow plug, which will burn off any unburnt fuel that might be left in here, and then slowly work through a cool down cycle before it switches off. Okay, well that concludes this this video. Just reiterating again, these units run very, very clean, but if it's in the setup and the operation of them, you must have plenty of air intake to make the combustion, no restrictions in there, and no restrictions in the exhaust. Alright, thanks for watching.